All right. Hey, friends. Hey, Cabral. How's it going? All right. Welcome to episode 8, I think. Right? This is the 8th episode so far. Yeah, we're just going to continue with domain-driven design, and I got some notes here. Continue working on the aggregates. Don't worry about Django's user model, because we did, or I did, last stream. So we're not going to worry about Django's user model. We're not going to worry about any database models as well. We're just going to implement logic. That's it. That's it for today. We're just going to continue with the aggregates. We're just going to continue working on the logic. No database models, no nothing. And also have another note to look into custom error classes, because we haven't done, we haven't created any custom error classes, but we do have some, we do throw some errors. Okay, so yeah, it's gonna be pretty chill episodes. Nothing new, no new concepts at all. Hey, Cinematic, how's it going? Yeah, no new concepts. We are just going to keep building some logic, right? Yeah, let's begin. Okay, let me see here. Okay, good. All right, here we are. This is where we left off. We basically have the aliases value object, and we also wrote some unit tests for our aliases value objects. But there was an interesting article. Let me go here in my Discord channel. And this is Evie. He's regular in my streams. He shared me this article on LinkedIn about unit testing, and that says do not unit test directly your aggregates, etc. And Evie actually clarified what the actual article meant. So Michael, the author of the post, is one of the best French people about test-driven design and domain-driven design. The reason why you target the use case or command handler application service, same here, it's basically just the application layer, basically, is that you want to not block future refactoring. When you add a test, you put a lock on something. That's true, right? When we created a test for the aggregate, not the aggregate, we created a test for the aliases value object, and we're basically locking the implementation. If the if the implementation changes, that means we need to change the unit test as well, right? Natural. If you put too many locks on technical stuff, you will lock the how the things are done today. What you really want to put a lock on is the what you want to do, or the behavior. That's why the article suggests that we don't test the aggregates or the value objects, or what we did basically with the aliases value object. We don't test that. We only test the outcome, right? So for example, we might have a command that says create skill, and also add aliases to the skill, right? In that case, the test will be on the command itself, but not on the implementation of how the aliases value object adds the aliases. So we're only going to test whether after we invoke the command, we get back a valid skill with the aliases that we provided, right? Regardless of how aliases are added, whether that's like a separate property or it's just a list within the aggregate, does not matter, right? So that's what we want to test. We want to test the behavior, and that's when we need, that's why we need to test the either use cases or commands, depending on if we use use cases or if we're implementing something like CQRS, then that means that we're going to have commands. You use what's called a sociable testing instead of solitary testing. The fact that we decide to split or merge the entities or value objects is a decision that can be done when refactoring. That doesn't mean that you will create new tests if you decide to split if you decide to split a value, like a primitive value, into a value object. That means you gotta add tests then, right? If you're testing the implementation. But it doesn't mean that you will need to create new tests if you're testing the behavior, right? The behavior didn't change. It's still the same behavior, still the same functionality and outcome. You just changed the implementation, did some refactoring, but the outcome is the same. I like that, you know, less tests even. And if the, you know, this is the opposite is you merge two classes because it's easier to work with. Doesn't mean that the behavior changes, just the how things are changed. So using sociable testing, no test will fail when refactoring. Even though you've merged two classes or you split one class into two separate classes. Sociable testing or behavioral testing, like if I invoke this command, will I get a valid skill with an ID with these aliases put into it, you know? That's basically behavior testing. And the test will not fail because regardless of how the implementation is done, the outcome is going to be the same. Yeah, using solitary, multiple tests can fail when refactoring. So that's basically what the article says. And I agree, you know, first and foremost, less tests to worry. We don't have to write that many tests, you know? We didn't even need to write tests in the last stream for our, let me go, these ones for the aliases. We didn't need to really write them. We decided to write them just, you know, for me, it was the first time writing unit tests in Python. So I was like, okay, let's see how this goes then. But yeah, sociable testing or testing the behavior does not include testing aliases and testing, you know, individual functions like, oh, what is the add function going to do? What is the remove function going to do, right? That's basically what the article meant. And he also like shared another one. We can look into this as well. We can look into this, but yeah, the fact that you have unit tests directly on value objects, entities, and aggregates can slow you down if you need to refactor them. Now, let's see it later, and good job for the stream. Yeah, I'm down to actually look into this article. It's a pretty short one, but before I do that, let me just catch up with some of the comments, because I can see there are some comments in the chats. Hey Jovan, how's it going? Did you use Nest.js, and if you did, what is your opinion? I haven't used Nest.js before. In this project we're using Django for the API, and I'm thinking just plain React with Vite for the client side. And yeah, it's just going to be a CRA, no server-side rendering or stuff like that. And we'll see about the machine learning models. So far, I think we need to, I think we're gonna need to do some LLMs first, because turns out it's very expensive to run your custom LLM models on a server for like production. You gotta have some beefy servers, and well, like I don't know, I don't want to like spend hundreds of dollars per month just so I can have this pet project. So we might need to, you know, just use LLMs like ChatGPT or OpenAI's API or whichever is, you know, the best for the case, until we maybe reach that point where we can actually build some custom models. That was my idea, but you know, what can you do? And Fluffy says, hey, and I say, hey back. Fluffy, thanks for joining. All right, let me just be right back in 10 seconds. Okay. All right, so let's check this article, and then we're going to move into working on the aggregates. So far, though, what this means that if we're, you know, adapting this kind of testing, so we're not testing individual functions, but we're going to test, or we're not testing lower let me actually, I'm gonna try to explain this using using graphs. Okay, so we're doing domain-driven design, right? And that means we get to have some layers in our application. So the first thing that we have is, let's say, the client, which is React or whatever it is. I'm just going to say client. It's better, right? The client will send an API request to the API server, right? The API server has a handler, has an API handler. Is basically a function that, you know, gets invoked when we trigger that hey, when we actually trigger that API route. Now the handler, what the handler is going to do, it's going to invoke a command. For example, if we take or a use case, you know, depending on how we design. I think we're gonna go with commands. We did use cases for the last projects just so we can have, you know, something different. We're gonna go with commands this time. But yeah, the API handler triggers a command, and the command will trigger the aggregate root, right? And depending on what the command is, for example, it can be, I'm going to say roots with s in parentheses, because there can be like multiple roots, right? That is the command create a skill, right? The skill has a label, React.js, for example, but it also has aliases, just like plain React, lowercase React, uppercase React, React space JS instead of .js, etc., right? So these commands, there's the aggregate root, and the aggregate root can trigger like multiple value objects, and again, with s in parentheses, because there can be one or more. And this is what the testing philosophy means. Do not test further down, but like tests over here, maybe on this level. You can test on this level because this is an API handler, and it's very dependent on what API framework you're using, right? So don't test there. You have your commands or use cases. Test them instead, regardless of how the aggregate root is defined or how many value objects it have, or, you know, what the implementation is, or is it just a single class versus multiple classes. We don't care. The command expects to, you know, create a skill with those specific aliases, and the output should be that, regardless of the implementation. So the testing philosophy basically says do not test in the bottom layers, right? Do not test in the bottom layers. That's the thing. And if we were to draw this in like a clean architecture, it would look something like this. Basically defining the layers, it'll look something like this. This is going to be the presentation layer, and I'm going to make this as like this, basically just the API handler. Yeah, this is the presentation layer. This is going to be the application layer. Right, this is going to be, if I can select these two, domain layer, and it captures both of them. Right, so we should not be testing any of the domain stuff. We should be testing on the application layer. Maybe now it's clearer once, you know, we define the layers and where everything lays. I think it's much clearer now. Do not test the domain, because, you know, domain is like just basic logic. Do not test the domain. Tests, you know, worry only about the application layer, and that would, you know, that would make it easier for us in future when we want to refactor the functionality or how we build things. Right, the application becomes more complex, and this is outside. We take into account the client, whatever it is. Maybe a mobile app, could be React, right? But yeah, basically, we're not testing implementation. We're testing, we're not testing the implementation. We're actually testing the outcomes. That's how I understand the whole thing, right? And it does make sense, right? It's better for us in the future. We get to write less tests, and like in general, but the functionality will remain, the core functionality will remain well tested, right? So yeah, this is how I understand it. Cool. Oh, not this. I'm just going to say test this, not this, and I'm just going to point some arrows. So that later, when we want to, you know, swing back and talk about the why we don't have unit tests for the domain layer, we're gonna know. All right, so what color did we use for the layers? Domain is yellow and application is red. Okay. Make sure that we also do that. Domain and also cool. There we go. And presentation was, damn it, I shouldn't have closed that. Presentation was blue, I think. Yeah, blue. Hey Yaka, how's it going? You said hello when you joined. Okay, this is what we have. What? Okay, we need to get these all the way back. Sent to back. There we go. Okay, we are testing the application layer. We're not testing the domain. Because domain is how we do things. We don't want to test how, we just want to test what happens when we invoke them, right? That makes sense. Okay, now it's perfect. I got something, so I'm ill on the couch. Perfect time to sit back and listen. Oh, I'm sorry. Hope you feel better really soon. All right. Okay, so this makes perfect sense. We did some, you know, we did write some tests, but we're not gonna keep those tests. We're just gonna remove them later on. I just wanted to see how, you know, what the developer experience is for writing unit tests in Python. But so far, yeah, really good. Okay. That means we get to continue working because we haven't even got this layer and we're yet to implement this. So we gotta work on this first. Finish this completely and then we can go on here. Okay, maybe even like actually, let's like take an MVP approach where we do have the domain only for the skills. We don't want to work on other domains. Let's see how we can create a command for the skills. Yeah, it's gonna be better. Basically, take a vertical slice of all of the layers, like a tiny vertical slice, instead of building out a whole layer and then the whole layer. That's not smart. All right, what do I have here? Change the URLs, that's good. This is the endpoint. And there's also the root domain for the user that we started to work on, but it's not a good idea to do that now. So I'm just gonna say changing URLs plus root aggregate for user, but we're not going to continue working on it. I'm just gonna keep it in the project. Now, here's the current situation. We have the aliases value object. The aliases value object is being used in the skill root aggregate. This is the root aggregate, right? It has a label, react.js, and it has the an instance of the aliases, which, you know, React, lowercase, uppercase, React space JS, etc., etc. So all of the aliases will go there. Here's our constructor for the root aggregate, and we basically just pass the ID because we are we do expand we do extend the entity class, which takes care of the ID for us. And the ID is not a UID, it's not a number, it's actually, if you're interested, I need to go here now. It is actually a snowflake ID. And we built this snowflake ID generator, I think in the 4th episode or something like that. And it basically looks like this. It generates a number that is guaranteed to be always unique, and it also takes into account multiple workers. So it can generate unique IDs in a distributed manner as well. So if we have multiple workers, like multiple servers generating IDs, or, you know, microservice architecture, or I don't know how it's called, but like replica sets for, not for databases, but like for servers, I guess workers, right? They have their own ID, and the IDs that are going to be generated are going to be worker unique, and also timestamp unique. And there's also a sequence, and there's also an epoch. So pretty cool thing. Thanks, Aaron, for suggesting that we implement this. But yeah, the entity has a value, has an ID value object that generates a snowflake ID, and that's basically it. So we have that. It's in the skill. All of the changes happen through the root aggregate. So for example, if you want to add an alias, we don't add it on the aliases property, we add it on, you know, on the root aggregate, because all of the changes have to go through the root aggregate. We also implemented that here, as you can see. And now, I guess, you know, this is the logic. We are ready to create a command or a query that will just allow us to create a skill, etc. The commands, they take in data, like JSON data or plain objects data. They take in data from the presentation layer. Maybe they do some validation in there, like make sure that the data is valid. And also use these aggregate roots to achieve something, right? Create the skill with the aliases, etc. And once they have the object and everything is cool, everything is valid, they pass it off, the whole object, the whole aggregate root, they pass it off to a repository. And the repository implements the database driver connection, right? And it will save those things to the database. We don't have that right now because we don't have a database model for the skill entity. So we're not going to save things to the database. We're just going to create them, right? We're just going to create the skill and just return it from the commands. And that's what we're going to test, basically. We're going to write unit tests on the command that make sure that, you know, when we pass this JSON to it, or this plain object to it, we get this type of data back. So that's the general idea of, you know, how we want to approach this. So yeah. Let's start. Here's the skill application, and you don't actually see this, but we're working here. Let me actually collapse this so there's more space. We're working here now in the application, and we can have like commands and queries, directories inside. Let's actually do a refresher on CQRS or CQS maybe. It is built, or it is designed so that you can have scalable way and split reads and writes. So for example, the UI, or in this case, that would be the route handler, triggers either a command if it wants to mutate something. So that's like create, update, delete. It triggers a command and it writes into the write database, which will update the read database. The read database is mirrors the write database. We don't have to do that. And not all of the projects do that. But then if we want to query, we just query from the read database, right? And this allows, like, this is basically for scaling. If you have millions of users, and if you have like write heavy or read heavy operations, hey Yusuf, welcome. You might want to implement one type of database. I don't know, like a Postgres with the write aheads enabled for writing, but have a faster read database. I think Mongo is like faster for reads that will try to, you know, synchronize with the data in the Postgres. So you'll have something here that will, you know, achieve the eventual consistency between these two databases. But when you want to read, you read from the Mongo, which is faster on reads. When you want to write, you write in the Postgres, which is faster for writes. Let's say, you know, I haven't done too much research into that, but this basically allows you to achieve that faster reads and also faster writes. And it's pretty big, especially in like enterprise and .NET. So this is how it works. There's also CQS, I think. CQS design pattern. Yeah, which is without necessarily two databases. I don't know. There was some differences between CQS and CQRS, but nevertheless, let's look at some Django CQRS DDD site github.com. Let's see some, you know, open source projects that implement CQRS and domain-driven design, so that we can just look at what happens. Edward, good morning. This does a synchronization. Check out this one. I remember we did have some repos. This is in PHP. It's not the same, right? Let me check the Discord. I think we shared some links here. Someone shared some links on repos we can look at. So this is the Mediator design pattern. Turns out there's a library for Python for the Mediator pattern. There's the command, create user command. There's the create user handler. You create the mediator, you register the handler, and then you send that command to the mediator, and you get the result back. So this allows you to do some dependency injection as well, like you split the command and the handler this way. So for example, in unit tests, you're going to pass a different handler that doesn't use persistence maybe, or I don't know. Or you can even like construct, taking the persistence, like taking the repository from the arguments here. and the mediator library will just invoke that command. Yeah. This looks like, oh, this is in .NET. Yeah. This is in .NET, but there's also a Python one. It's a port from the .NET one. There's also decorators, which is cool. Okay, let's learn a little bit about the mediator. I know that I've used it before. Oh, not here, not on the file. Let's just do explain the mediator design pattern. List its pros and cons and where it should, or what, and in what types of projects it's meant to be used. Okay, let's see what the robot says. Okay, so the mediator design pattern is a behavioral design pattern that defines an object, that's the mediator, that encapsulates how a set of objects interact. This pattern promotes loose coupling by preventing objects from referring to each other explicitly and allows their interaction to be varied independently. Yeah, but basically, like, isn't that like the same responsibility of like DI libraries as well? Do you think the RPC and React query is still valid in Next.js app router? And what has been your experience using RPC over REST? Is it good? I haven't used the RPC like ever. I've used the next actions, which is basically RPCs. And RPC is when you want to just trigger a functionality, you know. If you're using forms, you know, you can like just use the platform. You can just say, here's the form action, and let the browser send the request without necessarily implementing, you know, implementing libraries like that. And it's going to be REST as well. But one downside of Next.js actions, if I remember correctly, is that they get executed synchronously. So if you have like multiple actions one by one, like the output of one goes into the other, etc., that's very slow. Maybe not the output of one going to the other. I don't know what the use case is. I just read that Next.js actions, they get executed synchronously and not in parallel. So if you have multiple actions, if you're invoking multiple actions, that's going to hurt your performance. So that's not good, right? But I don't have too much experience in that space, like RPCs and stuff. If you can do REST, just do REST, you know. All right, so back to Mediator. The pros: reduces dependencies by centralizing communication. It reduces the dependencies between communicating objects, making the system easier to maintain and modify. It simplifies the object protocols. Objects no longer need to know about the methods of other objects, simplifying their protocols. Centralized control centralizes the control logic, making it easier to understand and manage. Damn, this is just repetitive. And code reusability, of course, because it's, yeah. It does include, introduce some complexities. Yeah. Can become a monolithic class. There's a performance overhead. Single point of failure. The mediator can become a single point of failure as all communication passes through it. Okay. AI powered, what's the plan to integrate AI on resume app? Creating templates? No, basically what the general idea is to have a resume, have a job listing, and then optimize the resume, the data that comes from the resume, according to that job listing, right? So if you have a lot of experience and you just want to apply it as a front-end developer, only your relevant front-end experience will be in the resume. So that's the general idea of where we want to use AI. It's basically a resume generation. I think the main idea behind RPC was microservices, or that communication between internal services. That's true, Martin. Yeah, the idea was so that microservices can communicate between each other, not like client server, but they brought it to the client server. They put it on the forms, which I guess is cool. You know, you don't have to write a fetch if you want to send data. I can see how that's like better for DX, but you should be aware of, you know, any like drawbacks that you might be introducing in your project just by implementing RPCs for the sake of implementing RPCs. You know, that's why I mentioned, like, if you're trying to send the data from a form in HTML, just let the browser do that. You know, add the action, use the action attribute on the form, and just let the browser send whatever it is, and add names to your fields. You know, that's much better. So you're not writing fetches, but you're not also implementing RPCs, right? And where would you use RPCs? You're not going to use an RPC to fetch data, right? It's mostly for actions, for sending data. The user did something which resulted in some data being generated or, you know, captured, and we want to send that to the server. People use RPCs for that. But yeah. Mostly for invoking methods. That's what it stands for, right? Remote procedure call. Like, you have a procedure, a method that's remote on a different server, and you want to call that and get the results. It's still HTTP. It's just an, you know, different developer experience. But I would say put developer experience behind performance and, you know, just complexity and stuff like that. If it makes sense, then use it. If it hurts your developer experience but still makes sense, then so be it, you know. Okay, but basically, yeah, this is the mediator pattern. It's for decoupling components. And if you want a centralized control where you coordinate interactions between objects, yeah, that's basically coordinate between like commands and queries and implementations. Let's see like a graph. There was a design patterns.com, right? No, JavaScript design patterns. Oh, patterns.dev. This is a pretty cool article. Not article, but like a doc site. I'm going to paste this in the chat so you can check it out. Let's see if they have, yeah, they do have a mediator. Makes it possible for components to interact with each other through a centralized point, a mediator. This is in JavaScript, but we'll do the same thing with Python. We already have the library. Yeah. Yeah. Yeah, basically, instead of doing this, multiple components being aware of each other, where they are, and, you know, holding references to each other, you're basically doing this. So if this component doesn't exist, if we remove this component or refactor it or, you know, do something to it, we don't need to update these ones. In this case, we do, because they hold the direct reference to this component. So pulling this out will just pull on all of these strings that you see, the lines here. But this, nope, this is centralized. Yeah. Okay. I'm actually happy with. I'm actually thinking about implementing this. This is good. Yeah. So create user command and a handler. Right. The command holds any data inside. It's just a data class that holds data. And we create the commands and then we pass the command to the mediator. But before we do, we need to register that command with that handler. And that's it. Right? We're just sending commands to the mediator. It knows where the implementations are. This looks good. This looks very good. So I'm gonna go here now. I'm sold on this. I'm gonna go to the requirements.txt and I'm going to add, let's see what the version was, or actually we were here, 132. So that's Mediator 132, was it? Yeah, Mediator. And I'm just going to do pip install -r requirements. Cool. There's the Mediator already installed, and now we're actually ready to implement it. So looking at this, the Mediator basically does this. You gotta have probably the same instance of the Mediator. No, it can go into the shared. Yeah, it can go into the shared, and this Mediator registers these. Or we might even have, yeah, we're going to have one mediator per application or per domain. So for example, in the skills domain, we're going to have a mediator that only registers skill-based commands, right? It's going to be clearer. So in our application, we can go into the skill. Here's a presentation. We have the URLs here. We still don't have anything, but we're going to register our API endpoints here. There's going to be like a different file where we define all of the endpoints, but we should also have a container here. And that container is basically like a dependency container. We're going to register the mediator, instantiate the mediator, and register all of the commands and handlers there. So when we are in the, let's see, when we are, because that's for the commands, we use commands in the presentation layer. So that's where the mediator should be, in the presentation layer, right? We're not going to, yeah. Okay, cool. Let's do a container dot, not ts dot py. We're not doing TypeScript now. And we are going to do this then. We're going to basically do this. Only for the skills, right? Probably mediator, yeah, that's correct. We have a command and we also have a handler. And these will come from the application layer. We'll just import them here. Yeah, here's the instance, and we're just going to register the commands where we have them. And we're going to use the mediator inside of the handlers here. So from the presentation layer, we dip into the application layer. That's fine, to pull in commands and handlers. But we use them here, and we just use the mediator in the and also commands inside of the handlers. Okay, that's good. Here are our commands, here are our queries, and now we can do, let's say, create skill command.py. It's a long file name, but we're only going to define the data class here. Only the command that's going to take in the data, just plain data, take in the data and just, keep it. So that we'll send that command to the mediator and the handler will unpack it. Nice. And if we're doing unit tests, we're going to register a different handler so it doesn't use a database. We're talking about unit tests, right? Because we are going to be testing the commands. Cool. All right. So I'm going to import data classes, and I'm going to say data class create skill command, right? And we can say keywords only. Then we do data classes like this. What am I missing? Okay, let's remind ourselves. Data classes in Python. I'm just gonna be brief in this case. Data class, and that's it. Oh, from data classes, import data class. Okay, we did this. Oh, import data class. No. From data classes, import data class. There we go. And now inside, we should just have keywords. Okay, we'll circle back, but yeah. Cool. There we go. Thank you, robot. Now, the skill needs to have a label, and that's going to be a string. And I'm just going to add aliases, and that's going to be a list of strings, okay? The skill should not be using any entities or value objects. It should just probably use like primitives, right? Because we are sending data over HTTP. We're parsing the bodies and the requests. That's going to be like strings, numbers, booleans, you know, primitive values. And the command should receive them. And then use the entities to create instances from them. Cool. Okay, so here's the command. Now we can go back to the mediator here, and we can say we don't have implementation yet. Let's actually do that. Maybe we should have like a create underscore skill folder and like move this inside. And I'm just going to remove this to command.py. And handler.py is going to keep the handler. And we're going to, you know, define it here, but we can have a different handler like tests underscore handler or handler underscore test that will define a different handler, right? So let's look into the handler now. There's a handler, there's a handle definition, and it basically takes in a command. That's it. And whatever it does, it does. And then it just returns something, right? The result. Okay. This is not going to be a data class. Create skill handler. We're not going to extend from any, you know, from anything right now because we don't really have a base class in mind. There's nothing repetitive. There's no IDs or anything like that. So far we don't need to create a base class, but we can like keep our mind on it for later on if we want to somehow formalize what a command is, what a handler is, what the handler accepts, etc. Cool. So we're going to define a handle method that takes in the command, create user commands. And now this, in this case, it's fine. The handler can hold a reference to the command, but the command should not be aware of any handlers. Create user command, and I'm just going to from dot command import. It should just show up. There it is. Create skill command. User. Create skill command. There we go. So now if we do command dot, we can see we have the label and also the aliases, right? We have the data. We can basically create. We can use the aggregates inside of the handler to create a skill, to add, you know, stuff to it, and then we'll just return it, so that we can, you know, apply some tests to this. Yeah. Hey Srivashu, how's it going? Is it Srivashu or Srivasu? Let me know. All right, check this out. Mediator. Actually, first let's import some stuff from skill.application.commands.create skill imports. I can bring in, well, dot command imports. There we go. Okay, so I think I'm going to create like a barrel file here, so we can import these two. init.py inside of the create skill. And what I can do, hey Nicola, how's it going? The second one, soft S. Srivasu, nice, thank you. Okay, there are barrel files in Python as well, and that's I'm talking about barrel files like in JavaScript. And that's the init.py file sitting in a directory. Let's ask the robots how to re-export classes from an init.py file. With the dunder all. Okay, so that's how it's done. So we can do from dot command import and just import the create skill command. And then we can say this is too there's not enough space, but let's say from handler imports create skill handler. And now we can say dunder all equals and a string create skill command and also create skill handler. There we go. So now having this barrel file, it doesn't behave like classic barrel files in JavaScript, but having this barrel file, we can go and from create skill import, and I get to have them here. There we go, create skill handler. But first I'm gonna bring in the commands and then the handler. How about that? Right? And now we can say mediator dot register handler. There's a behavior as well. Interesting. We need to look into that, but register the handler, and we put the command first and then the handler, right? Create skill command, and we don't instantiate it, probably. And then we say create skill handler and we instantiate it. Do we? We don't instantiate it. Let me just organize these imports. And I think I should see the actual. Oh, look at that. The API is a bit different. Define the requests. This is a query, it's not a command, but still, we don't care. And then define the handler function. And because we have get array query, because we have the type here, we can just add this. Oh, look at that. We can just add this. And how does it know? We don't need to send async. We're just going to send synchronous. Okay. So it's based on the like the type. Mm-hmm. Let's see Srivasa's comments. Lazar, quick question. For your NeoVim setup, did you start with something like Kickstarts, or is it fully custom setup that was born from something else? I started off with like a custom setup using Packer, but then I moved over to LazyVim because it just, you know, it ticked all the boxes. So I'm just, right now I'm using this, but I am thinking about, you know, switching to just to Lazy NeoVim, which is only the package manager under the hood, because it's like more stable. I had some issues last stream. There were some updates. I hit update and, you know, it broke some functionality. So if I'm doing an update, I guess I want to like control the versions. Akashay, how's it going? Welcome. So yeah, I'm just using this one, lazyvim.org. Okay, so looking at the mediator, when we, okay, interesting. So we could just like add a handler, decorator, and that's it. We don't need to marry those two, right? That's cool. We don't need to do this basically. Register handler. We don't need to register. We can just do this while we are in the handler. Okay, so interesting. In that case, it doesn't really allow us to register two different handles, right? Because this one just does, you know, register, get array query handler, and that's it. What if we have two handlers for the same command that we want to, you know, conditionally run? Let's see. I'm going to try to find condition. No, there's nothing conditional. Let's find the, let's go to the home page and actually, you know, like read the home page, see what's up. There's a different one. Mediator. Let's go to the home page. This one has 19 stars. Command. It's basically a bus, right? Local request bus. We register this handler. Probably can be synchronous as well. Print message command. And we invoke that. There's a data query. My cat is going crazy. Let me just do buzz that execute. Here's the print message command. We don't know what the handler is, so it's gonna be the handler. Okay. Yeah. This one is. Damn, dude. Do you hear the cat or you don't? Cause he's like yelling like crazy. Stop. um, this is just as good as as the others, to be honest. Maybe we should look at the like release histories to see which one is like more maintained. 2021. Okay. Let's look at the other ones. You can. 2021. There's an LLM mediator as well. There's a crypto mediator. And look at that. Apparently this one. Where's the repo? Okay then. Okay, if it's 2021, we'll just use, use this one. Yeah. That is, yeah. But I guess, that's the design pattern. What more can you do? I'm starting to work on a RAG chatbots with Olama 3.2. Well, I'm dealing with speed challenge. I'd love to see some of your content here. You have like a self-hosted model, right? I know that you can do that on your laptop and use it as like a personal chatbot for your own self. But putting that on a server, yeah. Putting that on a server, you need investors. You're going to need investors. All right, so register handler in this case just gets the handler. So why don't we just use, like the... Should we do... No, we actually should do this. So we only need the handler, so we don't need that barrel file, right? Yeah. Seems like it. Seems like it. So we only registered the handler, and the handler is a class that has a handle method, and it takes in a command of that type. How hard would it be to implement Mediator from scratch? I don't know. Shouldn't be like too hard, Or maybe it will, I don't know. The idea is that this is... You can even use this statically. So you can register a handler, and you probably, when you take in the register, the handler itself, you gotta read into the arguments, right? So you need to read in the arguments to see what the type of the argument is, what is the command, the type of the commands, and then like connect those two in like a map. Maybe you can use single dispatch for that. Hey, Patrick. What do you mean with the single dispatch? Hi. What do you mean with the single dispatch? Are you referring to like the static? Seems to have around 250 lines of code total in meaningful code. Yeah. How to implement your own mediator. It's a Python built-in. Oh. Interesting. You think we should do it? Like just implement our own thing in the shared folder? Python single dispatch. Functools single dispatch. Right? Oh, look at that. So we can basically register a single dispatch. Thank you. Register a function or a class with the single dispatch. And then using the name of the function, we can do .register and register the command with the handler. And when we invoke the, let's see. Actually, this would be the mediator. No? When we invoke something and we pass in a command, and if the command is a string, right, it's going to print it out, just print out the string. If it's a number, it's going to, you know, it's going to double it. If it's a list, it's going to print all of them with their indexes. Right, and this is basically the mediator, right? This is mediator dot send. The send method takes in that request, which is a command, and based on the register type, we invoke different functions. So yeah, this really is, this really can be implemented by itself, like without using libraries. Yeah. At fun.register, and if you wanna do this, then you can do at mediator.handler. Seems pretty much the same. Although in this case it doesn't probably it somehow infers the type of the argument that is being passed, but in this case we actually pass in the type, which is still it's fine. It's okay. Yeah. This literally is what it is, right? Type hints, yeah. What about the behavior stuff? Behavior is basically middleware. You have the requests, and then you have the next function in the queue or in the line. You want to invoke that first and then append something to it. Then the next one behavior of all requests because is subclass. Behavior only for getArray query or derived class. Behavior for all requests because is subclass getArray query object equals true. Maybe we're not gonna need this, but yeah. Yeah, we can easily use single dispatch to like implement our own mediator. Right, this is it. And how do we structure this? We have single dispatch, right? And we need something. We need a function. And this is like the base function for that. So that can probably also be a class instead of a function. Class, and use single dispatch method on the method if you prefer. Yeah, so like have a mediator class. We're gonna use single dispatch methods and put it on the sends probably. And then we need to, how do we then because we're basically gonna define that in the shared folder, but we, for example, we need to export that so that we can do register inside of the handlers themselves, right? How do we do that? Because this is going to be a method. It's going to be at mediator.send.register maybe. I don't know. Let's try it out. This can be an interesting thing. So we'll go into the shared folder. We inside of the utils we have the snowflake ID. I'm just going to say mediator.py, and I'm going to say class mediator, and from functools we can import the single dispatch methods. Okay, got it. That's basically on the class. This is a function. Method decorator, descriptor. Okay, there it is. So we can say single dispatch method and define send. Hey Philip. Yeah. What are the options when you're trying to self-host an LLM? AWS with SageMaker for training. I think SageMaker is for training. I think I have seen Hugging Face. They have a service that scaffolds an AWS. Yeah, they are expensive. Let me see where that was. Hugging Face endpoints. I think it was called inference endpoint. Yeah. So Hugging Face have some functionalities. Like you can give Hugging Face the model, and give access to your AWS account, and it will basically, do all these things like deploy a container, use SageMaker for training, etc., etc. Hugging Face is your repository, but yeah, I think it does support some scaling. Yeah, I have seen some functionality. Yeah, like select your model, which one you want, choose your clouds, AWS or Azure or GCP, where you want your deployment to be, security level, and there it is. There's also like scaling stuff. There's a video on this. You can check it out. Yeah, pay for compute resources, uptime by the minute, build monthly. As low as 0.03 per CPU core per hour and 0.5 per GPU per hour is like the cheapest. So maybe this is the way to go. And this is for like any models, right? If you want to, yeah. If you want to do LLMs, then go to OpenAI probably. It's gonna be like the cheapest. But this is if you don't want to just use LLMs and you wanna have different types of models, ML models, then I think this is going to be the solution. But yeah, I am yet to get to that point. Okay, so this does something, right? Single dispatch method is going to receive, I don't know, a callback. And we need to invoke that, right? No? Oh, wait a minute. This is the mediator. What does this do? Oh, there is a send. Okay, so this might be like the... There's the init. Thank you, Philip. I appreciate you, man. Thanks for the kind words. Oh, thank you, Patrick. Okay, let's check this out. Someone created a module that acts like Haskell's data, maybe, but for Python. It was an investigation of the single dispatcher decorator. Okay, there we go. Combine them to define methods or on classes which act differently depending on the input. In the very last release in Python, a single dispatch method allows overloading the methods within a class using the same method we have shown before. We actually talked about this, I think, at the very beginning of this series, where we were like, okay, maybe we have a class that can have different types of like alternative constructors. We're talking about alternative constructors. Like I can send you a string, or I can send you an integer or something like that. Maybe this could be that. Yeah, we'll see. Just import single dispatch method and it will check the second parameter of your method. Probably the first one should be self. I guess that's what the author is trying to say. The first one is self and it'll just check the second one. And this is the second one. Let's provide a class C, which has a value and an add method, which behaves differently depending on what your input is. So we add single dispatch method on the add class. And the default one is, of course, raise a type error, right? You gotta use something like that. But then we use the add.register. So if we are in the mediator class, here basically, yeah, we don't even care. Or like we can do is just an underscore maybe. So here's the send method. And now we want to access the send method somehow, or like export it so that we can go into our handler here and add that, you know, and register it. Yeah. Okay, so from shared utils mediator import mediator, and now we can say mediator dot send, there it is, dot register. No, doesn't give it to us. Maybe it does. Here's send. Maybe it does. No, it doesn't. It says that it is a function, yeah. All right. In this class, in this case, yeah. What if we tried to do this then? Why didn't I? We can do that here, and that's gonna be fine. Let's ask the robot then. Just gonna do this, and I'm going to say I'm using the single dispatch methods decorator from the functools module, and I'd like to use it as a mediator pattern. How can I access the register method so I can register my handlers? Command handlers. Yeah, this is dumb. Shouldn't be like this. You're handling logic here. I don't want to handle the logic inside of the class. So I want to that's the moment here that we have this. What if this was like a static method on the class? Would that work? Or it can't be, because if it's a static, it's not gonna have the self instance as the first argument. Right, and we read that this one actually yeah, for the static method you can use single dispatch. Let's try that then. Maybe that's going to be better. Alright, should it be like this? Or if we're doing this, then we don't even need a class? Okay, here's mediator. Send is now a static. Do we have a... Oh yeah, we do have register. We actually do have register. No overloads for register match the provided arguments. So register needs... I think we forgot to instantiate the class. The mediator class? No? Yeah. Maybe that was the case, yeah. We needed to like get the mediator and then yeah, access the... But we can't do that in this case because we are in the application and we created the mediator in the container in the presentation. Yeah, okay, so a register, and what does it say? It says just register, but this is on the single dispatch method. I don't get it. Register is on self, and then we have the class, and then we have a function. There's dispatch, there's the registry, which holds all, and there's the register. Should this be a class now? Okay. It doesn't complain now. Yeah. Yeah, you're right, Elton. Yeah, this actually works. Like it should have been a class, not a function, basically. Okay. I guess this works. we have to see. We have to see. And now we have the mediator here. You think this is gonna work? Right, there's the handler. The command is just, we don't care about it. There's the handler, and now in here, we don't actually need anything, right? We don't even need this. It's already registered. We just need to bring in mediator from shared, instantiated, right? But it is a single, we don't even need this actually. Right? Yeah. Let's create a URL real quick. Just so we can like trigger it and see what happens. I'm just gonna do a mediator here. And we need a view.py. I'm gonna keep it super simple. Let me see how we did Django REST framework. How we did like these views, but from Django REST framework, or was it from REST framework? Single dispatch, there's the command, there's the mediator static with the single dispatch. It's just like print the default. We instantiate this and then we don't even need to make it static in this case. Like we can just say mediator.send.register. Although we do need to make this as a static. But this is going to be an issue here. This will print default, this will print command example. This is going to be an issue here because we need to pass the mediator to the handler. Yeah. REST framework.views API view. That was the case. Yeah, if we don't need to instantiate it, that's gonna work. Okay, this one doesn't matter. So now what we need to do is just trigger the mediator here, right? Oh, we need the command first. Why is this unreachable? Okay, it says no return. There we go. It is callable. It returns an object. And we send in a request that is the create kill command. Right? And now what we need to do instead of register, we should just say doesn't matter. There it is. Okay. I'm gonna boot up Docker Compose just because of the migrations. And Python manage.py run server. Okay. We have the API running. This one should go to skill/mediator. Let's see. Never crossed my fingers that hard. It was a get. Localhost 8000 skill/mediator. It was a get, right? It was a get. Right, go. Not supported. Oh, maybe we didn't even connect the URLs actually. Like the main URLs. No, I think we did actually. There is skill presentation rests URLs. That's here. And then we have mediator. And then we have get here. So what's wrong? Oh, good catch, Elton. Good catch. Thank you. All right. Takes one positional argument, but two were given. Because we need the requests, probably, right? And we don't care for it. but it needs to be passed. You have to pass a command to the mediator. Okay. Okay, so something happened. This got executed. You have to pass a command to the mediator. The type error got raised. It wasn't the... It wasn't... Basically, it wasn't registered. Mediator sent register. We didn't even touch this file. Probably, so it didn't get registered. But there's the command. Should have been, hey. Except a function. Like this. Without the self. Okay. No, it does reach. Still doesn't reach this. It's like this file doesn't get brought in, the handler.py at all. It's not. Yeah, it's not been discovered, and yeah. So that's the case. Okay. I guess then what should we do? This is the handler. This is the handler. If we put it in the view, no, actually in the URLs maybe, like here. Actually, I just wanna import this. No. Organize, that's it. Okay. Expect a response, but receive the class non-type. Assertion error. That was in the views.py. Wait, what? Oh, because it didn't actually, yeah. Look at that. See that? We didn't return anything. But we still printed the results. Yeah, it works. So I basically need to just return a response that comes from here. And I don't know, it's like 200. Okay, maybe. Let's see. Oh, it's data status. Okay, data is results. Status is 200, but in this case, I want to return a string. Yeah, hey there, hey, hey. Really good. That's it. That's it. If we change this, some aliases. Some aliases, hello, hola. Yeah. So that's basically it. This is like the simplest mediator pattern that we can build ourselves without, you know, necessarily relying to a library. Cool. Thank you, Patrick. Yeah. Looks good, looks cool. Let's figure out the import stuff. What can we do in this case? What can we do? Because we didn't have this issue, for example, in this library, because the registration happened. No, actually, from Mediator, you can actually run Mediator as like a statically without any instance. So how does it do that? All right, this is a static method. In this case, we are importing. Is this the correct syntax? Import mediator from mediator. Like that looks like JavaScript to me. Shouldn't it be from mediator import mediator? No, don't tell me that you can also do that. Yeah, docs are definitely wrong. That's the JavaScript imports. It's not the Python. It's the other way. Okay, but yeah, this basically this library has like a static. Yeah. Has a static method like mediator.send async, and we pass in the request, and it does also, where is it? It does also support decorators. But how does it discover the files? How does it discover that there is a getArray handler here, or a class that has a handle method, and it registers it? How does it do that? Statically as well. It doesn't say that we need to import something somewhere. You have the same issue with this library. If you don't import the file where you register the handler, then it won't be discovered. It's like the other way. We import mediator in our handler. Right? But the handler itself is never actually it's never been called anywhere. It's never been imported. So it does make sense from like discoverability standpoint. But maybe the docs are not, yeah, needs to be imported to somewhere. I guess the library doesn't say that. Maybe. Okay, then we're not gonna use it. This is okay. This is fine. It's within our control as well. So yeah, that's it. Okay, there it is. An option not really pretty is to import all files from the directory. Like import skill application commands. Like this, or just like import everything from the application. Is that going to do like cause any performance issues, or like if we're importing from a, you can use the OS module to iterate through the modules and then call import dynamically. Maybe that's what the library does as well. Let's check out the code actually. There's a mediator. There's an inspect as well. Extract the request type. If it's behavior or if it's a handler. Find behaviors. This is the request class. Behaviors items, and that's like a global property here. Okay, then That's probably what it does. Let's see, handlers. Let's see where it adds them. There's a register handler. But that's the thing. So when, yeah, because this is in a single file, that's the import, right? Like we call register handler. It is a static method. We pass the handler, and it just adds that, you know, adds the handler to the handlers here. So it keeps a reference to either the function or the class. So then when we instantiate from the class itself, from this class, and when we send async, there's going to be a request, and it'll try to find the handler that handles that request. So it just, yeah, there's a send function actually. Return start function. And there's also like a repeat, if I'm not wrong. Yeah, okay. So this library doesn't use the func tools that like we do. It's just all manual, and it's basically a map that holds references to handlers and behaviors. It uses the inspect module to like figure out the signature of the functions. It tidies up everything in handlers and behaviors, and when we say send, this one, it takes in the request, which is a whatever, right? Command, query, doesn't matter. It's an instance of a class. And basically, yeah, it's going to find the handler. If the handler is not found, it will raise an exception. If not, yeah, just go ahead and invoke it. I guess that's what it does. It's a lot like simpler than that. But because the implementation is different and we're using the single dispatch method here, we need to do this basically. Import all of these somehow. And just like keep them imported, but not, don't actually import anything from them or use them. So we might need to add the pound no QA. What does that stand for? No QA, like no quality assurance, or like just don't work for this line, maybe. Is not accessed. It still says that. Oh, okay. So there's a warning, and then there's a whatever this is. Okay. Is it gonna work if I just do this? And like bring in all of the whole application in there? No. So I need to explicitly bring in the file. Or just have barrel files, but that's like too much work. Application, commands, create, skill, handler. If I do this, now it's going to work. There it is. Otherwise, I'm gonna need to have dunder inits in all of the folders and just do the underscore all, you know. Okay, so functionally or conceptually, I like this application or this approach better because we're literally using, you know, native Python functionalities like the single dispatch, right? I don't like that I need to import empty, you know, not used handlers just so the file can be accessed. But on the other hand, I don't like this application or like this approach because it's like just manual. You're keeping some stuff. Hey Lane, welcome. To give more bad Python advice. Yeah, welcome. So yeah, thank you Patrick for the func tools. Definitely better than, you know, keeping maps of handlers and behaviors. So we're gonna stick with our implementation. If we can just like find somehow a good way, I don't know, to like have this be automated in a way or self-discoverable, that would be the approach there. But for now, just doing like plain imports, that shouldn't be as bad. That's what I'm saying. And yeah, all it took is this and then one decorator. Dynamic import, as Elton mentions. Use the OS module to iterate through the modules and then call import dynamically. Oh, that's what Django does. Okay. Okay. Let's actually take a look at that, and once we're done, we can actually, you know, might as well publish a Python library ourselves. Maybe that can be cool. Magic. Yeah, I like magic. All right, so let's figure that out. Python dynamic imports, and also Elton also mentioned the OS module. There's the import module. I would ask the robot. Let's see what it says. I'm like too noob into Python to actually, you know, have a starting point. So I'm just going to do, how can we iterate through the whole project? Find command handlers and dynamically import them so they're discovered and registered in our Mediator class. I'd use AI for this too. Yeah, let's see. Okay, there we go. To dynamically discover and register command handlers in your Mediator class, you can use the import lib module to import modules dynamically and the package util module to iterate through the packages and modules in your project. Here's a step-by-step guide on how to achieve this. First, define a base command handler. Check, we do have that. Second, iterate through the project. We need to do that to iterate through the packages and modules in your project. And then third, dynamically import modules. Use import lib to import the modules dynamically. Register handlers. Check if the imported module contains any command handlers and register them with the mediator. And we also do that as well. Let me just quickly check my calendar just in case I have some meetings. Nope, I got meetings later. Okay, step 2 is what we need to figure out how to do. Our commands, that's it. I like that Copilot also has access to other files now, and it uses them as context. I don't need to like highlight text. They got updated. Second, there we go, define the mediator class. Okay, so we have register handlers here. We defined the single dispatch method. It's a method in this case, but okay. And it's not static as well. So we'll see how, you know, how this happens. So inspect package util and also import lib. When we create an instance of the mediator, we call register handlers. And the package is your project. Replace with your project's root package. What root package? We don't have a root package here. We have a lot of packages. We have the skill, resume, the user. This is basically going to be a 4 within a 4 within a 4. Because we also need to loop in through the packages, right? Damn. Or maybe we can like figure those out. Okay. For module name in the walk packages, it's an array. We import that module, package.module. If it's a subclass of the command handler, oh, there we go. So we might need to have a base class just so we can have something to attach, to like identify this is a handler, right? Yeah, we can easily do that with a command handler. It's a subclass of the command handler and not the command handler class itself. Then we want to register the handler. And what the register handler does, it's... Oh, look at that. Is this correct? Command type, register, handler class. No way. This basically means that we don't even need to use the decorator, right? Yeah. So if you want to register a command handler, just pass command handler, like extend the command handler class, and that's it. This will pick it up. That's pretty cool, actually. Right? That is magic, though. Yeah, that is magic, though. Interesting. I like this. Okay. That means we need to create a base class. Okay. I'm gonna ask it again. Can I go to the previous now? Weird behavior. But yeah, let's go. We have the utils and the mediator file here. We're also going to need a base class for the commands and command handlers. So here's what we can do. Application commands handler.py. This is going to be the base or just command handler, basically. We don't say what, we just say command handler. And because there are no interfaces in Python, I think we needed to use like abstract classes, if I remember correctly. Basically, there should be a handle method that takes in a self and takes in requests. which is going to be of type command, and that's going to be command.py command pass, just so we can have it, you know. Hey Evie, how's it going? Okay, so there's the command handler, right? The handle, let's ask the robot, since there are no interfaces in Python, how can I create this command handler class into an interface? Not create, it'll understand. Abstract method handle, yeah. Okay, there's a different module. Good to know. From ABC, import ABC. It's probably abstract class and abstract method. So this is going to be an ABC. This is going to be an abstract method. There we go. So when we import this and use it into our handler, I don't think we need to do it on the command. We just need to, you know, keep it there. But let's go to the handle here, and I'm not gonna do this. I'm going to just do a class create skill handler, and it's going to infer, it's going to extend the command handler. There it is, auto import it. Now if I say pass, it should complain, no? It doesn't complain. Okay, so and now this should also infer from the command, shared application commands. It is a base class. There it is. Okay, so now it's fine, it's happy. Let's go back to the handler and see if... Oh yeah. Command is not assignable to create skill command. Well, create skill command is a command, but it's not directly. So command handler. There's that thing again. Command handler is a command, but it should be a subclass of the command, not command directly. The request command argument should be a subclass of command, not a direct command itself. How can I achieve that type? Let's see. Okay, so I need to do a type var. Yeah, and then import that type and use that. Okay. Okay, let's try that then. I'm gonna go here. Shared command, damn it. Shared command. Okay, NeoVim, there we go. Are you happy now? Okay, so I need to import, not here, but here, from typing import type var, and I need to define command type, which is going to be type var, and I'm going to, it's going to say, be bound to the command. This is what we're after, right? Yeah, this is the command type. So when we're importing, we're not actually importing the command type, we're importing the command type. Subclass of command. Okay. And now I need to go to the command handler here. And just say command type. Is this correct? And if we go back here, there we go. It is not complaining, right? This is a command handler, and the handle, oh, look at that. It is complaining. So it's probably that missing, wait, hold on. LSP restart, something's weird. Yeah, so I probably need to bring in import generic here, and then the generic like this. That's what it says. Okay, okay. So this can we need to set an explicit type. It will return either none if it's like a fire and forget, or an object of whatever. And we can raise type error here. What is the, when is this going to happen? This is basically the abstract method, which is you have to pass a command to the mediator. Let's just say that. Okay. And now we're cool. Now we're chill. Right? The handle can return, in this case it returns a literal skill created, but it can return anything. It can return 1, 2, 3, or it can say pass if we wanted to, and return nothing, because we explicitly mentioned, you know, it can be an object, which is everything, or nothing, or which is none. Okay, cool. Skill created, and that's it. Now I need to go back to the command handler, no, to the mediator, and implement the automatic scan. But I need to bring back the old query, because this one just got ruined. Okay, I'm implementing the mediator pattern with single dispatch, but I want to automatically loop through the project and register all the command handlers. How can I do that? Okay, there's the pretty much the same solution. Let's make this bigger so we can, it's more readable. There's the command handler. We already have this. Now implement a function to discover and register all the command handlers. Right, so we're here now. We need to import the import library, the package utilities, inspect as well, and there's a type. There's single dispatch, import type. Okay, organize them, save this. We should also import from, where are we here? We are in the shareds. Shared utils. No, hold on a second. From shared application command import command, and then again handler, import the command handler. Okay, there are the two. I liked the single dispatch method, honestly, but maybe this is going to work as well. Oh no, we do need this to be... Okay, so refactor the mediator to use a single dispatch method and a class instead of the send function. I don't remember what the difference was. How will it register all the handlers automatically if you need to inject the repositories inside? We're not going to do that. And that's the thing, we're not going to do that actually. Or maybe instead of doing it automatically, what if we just reuse this and don't do the automatic imports? And as Evie pointed out, if you want to inject repositories, so that we have like a dependency injection as well, we don't do that automatically, but we'll have a register method here that'll just take in the command type and basically do that. Why don't we use that instead? Can we actually achieve that? Let's refactor the mediator class so that it exposes register underscore handler method and allows me to manually register handlers. I need an opportunity for dependency injection, and manually registering the command handlers allow me to inject repositories in the handlers before registering them. How can I achieve that? That's a good point. And we're not gonna need to loop through these things as well. Yeah. Totally. Okay, let's see. The default send is this. Oh, look at that. Self._send is a single dispatch, and we use it as a function. And we pass the default send to it. You have to pass, but we can also have a register handler with the command type and also the command handler type, and then just register that. Beautiful. And now here's the handler. We can pass the repository if we want to. We're just going to instantiate it as we want. And handle is that mandatory function that we need to implement. So we can create an instance of the mediator and basically keep a mediator per application and not like the shared one. This is my repository instance. This is the handler, and I can just pass my command, my handler. That's it. This is basically the library, but instead of, you know, instead of doing automatic way, we do it manually, but we still have opportunities to do dependency injection, but we're also using the func tools, which is built into the language itself and not manually implementing a set. I think this is like the best of both worlds, to be honest. We just need to do this, and that's it. No static method, no nothing. Okay, dunder init. We'll just do self._send is going to be the single dispatch and we'll pass the default send, and this is that default. This is that default send. There's a self and there's a command, which is of type command. I think so. There's also C. Okay, so we use C only in the handler, but we can use command here. And yeah, just raise the type error. Now here, we define a send, the official send. Could potentially be none, so I'm just going to say none. We don't always need to, you know, return anything from the commands, right? Or do we? Yeah. And now for the register handler methods, we take in the command type, and it's going to be of type. And now we bring in the command type, which we need to manually import here. And also the handler. There we go. Self dots underscore send dot register. There we go. There's register. Command type and command and handler dot handle. And handle exists because we created an abstract class. Underscore because it's not used, and of course we're not going to need to use these three modules because we're not doing any dynamic registrations. Beautiful. All right, now we're talking. Yeah. Here's a handler. We just passed the handler as an instance because we want to inject some stuff into it, but we only invoke and register the handle method of that instance. But through the constructor, when we instantiate it, we'll actually pass the any repositories or whatever dependencies we want to pass. This is really clever. This looks really good to me. Yeah. Okay. Okay, so handler, we don't have anything here, but I can just do skill created requests dot label. That's correct, with aliases, and do this, and then do request dot aliases. Very pretty. And now check this out. We have this here. Mediator now needs to be instantiated, and I'm not going to instantiate it here in the handler. I'm not going to import this one here as well. I'm going to create a container.py where I will, from shared utils mediator, I will import the mediator from there, instantiate it, and we'll use that one, right? Aside from that, we can say create skill handler is create skill handler. I'll just bring that in. So far it doesn't have any dependencies, but let's say that it does, right? Let's say that it does. There's a dependency, right? Skill created with dependency. I'm gonna put it in like this, self.dep for the dependency. So we're going to provide the dependency outside, but when we handle this, we're going to pass the request from within the handler. So this should work. There we go. Now dep is going to be some repo in future, right? In the future. And now mediator Oh, we also need the command as well. Command. We can say mediator dot register handler create skill command. This should be a reference to the class, and this should be instance of the handler. Create skill handler. Okay, organize the imports, no errors. So now we have the command and also the handler. When we instantiate the mediator, we pass the repository. But now in the view, I'm not going to do this. Basically, I'm going to do this from .container import mediator. And now we're going to use this as like a lowercase mediator. And we're going to send hello Evie, right? And we'll just keep hello and hola. Okay, so now when we run this, we should see hello Evie back. Actually, we should see that, yeah, we should see that string that we just did. All right, the moment of truth. Let's see if what we did actually works. Of course it does. Look at that. Skill created with dependency. Can I zoom in on this one? No. Actually, we print it out here as well. Skill created with dependency, some repo in future, right? Hello Evie. So some repo in future is from when we instantiate the mediator. Hello Evie when the aliases are within the handler when we actually invoke the command or send the command. So there we go. Beautiful. This can be like a really simple library even, you know? It's really cool. But we achieved it. Simple. This is it. 23 lines. 23 lines, that's all. There's no maps, there's no sets, there's no like here's the command, here's the, you know, yada yada yada, nothing. Plus keep in mind the mechanism as it will be really simple to dispatch the domain events. Oh, for sure, yeah. For sure, it's basically the same, right? We dispatch a domain event and any, what is the event handler in that case? Yeah. Yeah. So now we basically created our own library. Maybe this is the one that you sent. And we checked the code, and it's basically implementing a set for the handlers and behaviors. We covered the handlers. We still haven't covered behaviors. But I'm going to leave that for, you know, when we need to have behaviors. Is that what we're using for the events? Maybe? But yeah, we don't need this anymore. Nice. It's a mediator, but it's like a manual mediator that we can actually inject some stuff. Cool. All right. Yeah, I'm going to, let's see, not the endpoints, definitely the command and the handler. These are the base classes. Definitely the mediator. That's like the big thing that we did. Create skill. And this one as well. Okay, let's just... Actually, no, I'm not gonna pass these. And these as well. So just the base classes and mediator. Yeah. That's our mediator. Really cool. Okay. Let's try out. How much do we have? We have been streaming for 2.5 hours. We should be good for like half an hour, 30-ish minutes more. Because I want to see about creating skills. You have a command bus plus commands plus handlers. The same can be done for event bus, events, event handlers, and if needed, the query bus. Okay, yeah, I saw, or we saw during the today's stream, we saw a repo that had like an event bus and a query bus. There was also another library that implemented that, but yeah. Oh, and also drew this diagram to clarify like what we're testing. We started to test this, but we actually should be testing this for the behavior tests, because we were talking about your message in Discord. Okay, let's go and actually create a command now that will create the skill. It will use the aggregate, and we're not going to save it to the database. We'll just return it, you know. Okay, I'm going to remove the dependency in this case. We'll keep the init, just, you know, why not? We'll go back to the container, keep the create skill like this, and go back to the handler so that we can actually create the skill, right? Now, we have the requests, and the request has, aside from all these other things, we has the label and aliases, but it's a string. It's a list of strings. We need to actually create the, or access the root aggregate, the skill root aggregate, and just instantiate it. So let's do that. From, actually here, from skill domain root aggregate, aggregate root, import skill. That's it. Okay, so it needs a label, an optional ID, and aliases should be the value object itself. We decided that that's what we want to do. So first aliases. Request.aliases. I think we do have a constructor that takes in a list of strings. And now the skill has request.label, and aliases are going to be aliases. Okay. I'm not going to do any validation or stuff like that. It's just going to return that skill. And because we don't have an ID, we're going to create one automatically. Okay, create skill handler should be done, right? So here we say create skill command. We're gonna keep hello Evi, and this is going to, instead of like result, I want to say skill. There we go, and we are returning go surround. Yeah, I mentioned that I want to refactor. Look at those, all these updates. I mentioned that I want to refactor because something is broken in NeoVim, and this is what I was referring to. Okay, go, there we go. Now G works. Sometimes the leader key doesn't work, so add surrounding in words. I want to surround this with curly. Does this work like an inline dictionary? Can I inline dictionary like this in Python? Yes, you can. Oh, with just a string key. And we're just going to say like 201 for created. Okay. the server is running. That means we can go back to Rapid API, send the mediator, I don't care. Oh, object of type skill is not JSON serializable. Look at that. Okay, so it apparently cannot serialize the root, the entity, the aggregate root. Interesting. Not sure if it's the aliases. If we want to save that to a string, or maybe we should override. Maybe we should override the some sort of dunder method. Let's see. I'm getting object is not JSON serializable for this skill class. What am I missing? Yeah, it's most likely that aliases. But it's manual. Aliases is technically iterable, but there is no dunder method that we can override. I'm using Django REST framework and I'm returning the skill through response objects. str or repr. Ah, there's a serializer. So serializers are technically presenters, right? You take in some data and you return to object method in my aggregates to return a simple object instead of an instance. Yeah, maybe that's what we, what we should do. And it's on the alias, not on the, because that's like a, or I don't know. Okay, so in the Django REST framework, there are these things called serializers. The first thing we need to get started on our web API is to provide a way to serialize and deserialize the snippet instances into representations such as JSON. We're missing that basically. We can do this by declaring serializers that work very similar to Django's forms. We don't know how Django's forms work, but we'll just keep on. Create a file in the snippets directory named serializers. There's a serializer from the REST framework module. We take in the serializer and we define a bunch of fields. There's two methods, create and update. Create and return a new snippet instance given the validated data. And update and return an existing snippet instance giving the validated data. The first part of the serializer class defines the fields that get serialized or deserialized. The create and update methods define how fully fledged instances are created or modified when calling serializer.save. But this is using the model. Snippet is actually a database model. And we want to do that through, we want to do that through a repository, not through, you know, the serializer. Or maybe it doesn't matter then. Okay, let's ask the robot then. We don't want to serializer.data. Do we need to provide the create and update methods to the serializer class? Let's see what it does here. Oh, it just returns a skill. Okay, I think I think I got it. The idea is that I don't know when the create method, you know, gets, that's probably for like serializing, but update is for deserializing. Yeah, we can do that, but we don't have the model. We need to like manually do this. It's fine though. It's gonna be okay. So I'm just gonna copy this. Actually, I'm gonna copy this. I'm just gonna get the whole class then. This is the class. We're just gonna go back to the view here. Paste this one. Okay, so skill refers to the aggregate root. I don't know about create, we'll see, but update is what basically is what deserializes this. Hey Robert, yeah, I'm using Kitty. The terminal. All right, there's our skill. So what we want to do is response probably equals skill serializer, and I pass in the skill, and then response dot, or actually the response is going to be response dot data. I think so. If that works. Well, let's see. Int argument must be a string. A bytes-like object or a real number, not ID. And what is it referring to? It's probably referring to the ID. Hey Leonid, how's it going? Yeah, it is referring to the ID. That's nice. We're talking about the ID type, which is in our entity. And it cannot serialize that field. So for example, if we go to the aggregate root, when I'm returning the response here, let's try that again then. But I'm actually gonna do this. This. So that we are explicitly returning a dictionary. But yeah, still the case. And it is about the value object that we have. In the aggregate roots. This might be okay, but this one is not. It does have an str to return it as like a string. Int of value. Why int though? What are we setting? Hold on a second. Oh, the ID is an integer field in this case. Well, yeah, it is not. It's not. It is a nested serialize. Like it might be we might need to implement a nested serialize. So let's see. Instead of this, yeah, I'm gonna say what is wrong with you? Okay, new. There we go. Yeah, so we might need to like do something for the integer fields. And also look at that. This is a list field, and inside there's like a char field. Maybe it should be like a string, but we'll ask the robot first. My ID is actually an ID class that's a value object that holds an integer inside. How do I define the ID property in the serializer? Custom serializer. No. That is way too much work. Way too much. What if I just say that it's a string? Char field actually. What if you try to serialize it as a char field? There we go. Aliases object is not iterable. Okay, so in this case, it says that it's a list field. But the object is not iterable. It technically is. We override the len and the contains and the add and remove. But we need to make this iterable. How can we make this class iterable? I guess it's like extending it from a different class. Oh, there's an iter. Okay, iter. You can now iterate over the instances of your alias classes. Beautiful, beautiful, beautiful. return self aliases. There we go. Cool. Cool. Okay, so this makes this iterable. When we go to the aggregate roots for the ID, I set it as a character field, right? But if we go to the ID, there is a str, which is being invoked when we serialize it as a character field, and it will return the ID, but just as a string. So it's pretty much the same. It's not gonna be an integer when we receive it, so the client will have to cast it, but I feel like this should work now. Bam. It does work, right? Okay, so here's our skill. Here's the ID. You can see that it is a string, right? Here's the label, hello Evie. And the aliases is a list with two, here's a row actually. Yeah, this is better. The ID is not a number, so it needs to be casted. There's a label and aliases, an array of alias. That's all. Right? So yeah. I wish the ID was like a number though, because we do need to return a number. The API should return a number for the ID, not a string. And the robot said that we need a custom serializer, like a custom field serializer. ID field, yeah. 2 representation and 2 internal value. Damn it. Okay then. Let's actually do that. In the shared utilities, I am dumping everything here. I have no idea how to, you know, like organize these. There's just gonna be utilities. So I'm gonna create an ID field here. And I need to ask the robot again because it's stupid. It basically cleared all the history. Define an ID field serializer from the Django REST framework that uses the ID class and serializes its ID property. You said that it's a hidden feature to be able to have ID strings for UID. Yeah. All right, this is what we're after. So we need to import framework import serializers, and this is our serializers field, our own ID field, to representation. We'll take in the self and also the value, and if it's instance of the ID class that comes from shared domain value objects, then we need to return the value.id. Otherwise, we need to raise a validation error that says expected an ID instance. And I can say an ID value object instance, because we can. And that's 2 representation, basically to return it as an integer, but to internal value, data is going to be an integer, and we're going to try to return an ID where the ID is set to data, right? Yes, the ID is integer or none. The data should be integer, but we're not going to do the type. We're just going to say if the type error or value error, gets raised, we want to do accept and I expect. We want to do raise serializers validation error invalid, damn it, ID value. There we go. And now we can just use this. Okay, cool. There's our serializer, so we can go back to skill, go back to the where view, and instead of the char field, we can say that it's going to be an ID field, which comes from the shared package. The ID is not a plain integer. It's a value object class that has some behavior, so we needed a custom ID field serializer. Look how it looks like. Application, actually not domain, value objects ID. Here's how it looks like. It's a value object. It does have an int, like an ID inside, but it's nested, right? It's wrapped with a class that has, you know, some behavior. It like auto generates the ID. So that's why we needed to create a custom serializer, field serializer, to return the nested.id inside. That was the case. Now, if I run the command, like if I run the HTTP method again, this is going to be a number. It's not going to be wrapped with double quotes. Bam! How about that? See? Now it's just a number. And there we go. Even the type is like 42 instead of A. It's not a character, it's a number. So, serializers complete. And we also have dependency injection. That means we can, you know, inject any repositories we want inside. Yeah, we generate the ID not in the database, but in the application level, in the domain level actually. That's where we generate it. All right, this has been a success. We have done a lot of things, and I'm getting more and more comfortable with Python. We still don't have any tests. I'm just going to delete these tests. But we do have a command that we can actually test now. Right? We're going to try to create a skill with a specific set of aliases and labels. And yeah. Yeah. It does do the it does auto generates the model level. But we actually, yeah, we don't even have models right now. And when we define the model, we should just be careful to define the ID as like a primary key integer field, not auto incremented or something like that. Yeah, so we are relying on our own ID. And that's the thing. And it works both ways. Like we generated on the in the domain layer, but then also when we read it from the database, we actually we do have a way to get it from the database and like construct it from the database. So we have a way to set the ID from the outside. And if we don't provide an ID, that means we're creating an object, right? It's just going to create its own ID. But wherever you are, at whatever point you are in the application, in whichever layer you are, when you create a skill instance of the aggregate, of the entity itself, it's going to have an ID all the time. If it's creation, there's an ID, auto-generated. If it's reading from the database, it's going to be the ID from the database, which was previously auto-generated. So yeah, yeah, this is the first time that I'm taking this approach as well, where we create the ID outside of the, outside of the repository or outside of the database layer. It's basically from the outside. And that's why we also use the shared ID. That's why we also use the Snowflake ID type of data generator. So, we make sure that it's always unique. And this is how the Snowflake ID generator looks like. We basically saw a Medium article that implemented this, and we did the same thing. We just tried to understand that. Power to you then, yeah. Thank you. But yeah, it's using timestamps. It's using worker IDs in case, we're doing this in a distributed manner. Like if we have multiple workers, multiple Docker containers that, are tied with the load balancer, then the worker ID is going to be unique for each worker. And when those workers auto-generate an ID, they're gonna be like the same. For example, if two servers try to create an ID at the very same millisecond, their worker ID is going to be the thing that differentiates between those two IDs, even though they have been created at the very same millisecond. So yeah, it is also distributed friendly. So we can have multiple workers, multiple Docker containers that service these requests, with a load balancer. But even that, we won't be generating duplicates. Yeah, that's the thing. And if we do, and if this is like an asynchronous Django project, there's a sequence. That sequence differentiates between two IDs that are on the same worker on the same timestamp. There's gonna be a sequence. So yeah. Yeah. It's always gonna be unique. And that's the thing. And yeah, this is how it gets like constructed. Aaron actually suggested that we use this or look at this. I'm not sure about like the performance of Snowflake IDs. Not sure like how, because we're getting the timestamp, and the timestamp is just time.time. That's not super, that's not slow. And if we're not talking about the same timestamp, we're only doing this basically. We left shift the timestamp by 22 bits, the worker ID, we apply a mask, so we get only the, what was this, like the rightmost 10 bits, and the sequence as well with the rightmost 16, and then we shift the worker ID. I don't know, some binary operations here. We didn't look too much into it. We just followed the formula for generating Snowflake IDs. But yeah, they look like this basically. It doesn't even give away like what the type is. It's always a number. Might be like auto-generated, a random number. You don't know that it's a Snowflake ID. Like you can know that it's a UUID because you'll see the format. So this is how it looks like if I keep pressing it. See, it's like always incrementing. That's what happens. Yeah. All right, cool. I guess we're gonna do tests in the next stream on Friday. Right now we do have the create kill handler. We implemented the Mediator design pattern. We actually implemented the Mediator ourselves, and that was really cool. Thank you, Patrick, for motivating me to go ahead and look into, you know, just create Mediator myself. But yeah, that was totally worth it. Now we basically have the solution we wanted to have, and not just use the library, because the library did not allow us to do this, to just inject dependencies, and now we can. So I'm very happy with this. Very happy with this. We do have the command. We'll just, you know, apply some testing in the next stream, and that's when I'm going to remove the tests, the unit tests from the this one. I'll show you now. Domain aliases test. That's when I'm just going to scrap this whole block. Hey AF, how do I like Django so far? I don't know. Like the only Django related stuff that, you know, so far I have touched is the serializer and the DRF stuff. So far we've only been doing, you know, plain Python stuff. Yeah. We're just like coding classes that do stuff, and that's it. But yeah, I'm yet to get into the whole Django stuff. Like there's a lot of utilities, you know, and tools that come with it. So I would love to like have the opportunity and time to just be, you know, super proficient in it. I will admit I was a little shook when you said you had no models yet and it's already episode 8. Yeah, we don't, but that's the thing. The models will just sit between the repository and the database. We're going to implement mappers that will map from the aggregate root. Basically, it'll take a skill entity and it'll convert it to a database model, instantiate it, and just, you know, pass it off to the database to be saved or updated or deleted or whatever, right? But that's going to be like that's the one of the thinnest layers, right? The aggregate root is pretty big. That's where the logic is. What else? We have the value objects as well. We have the commands and the queries and everything. The database models is just literally like put this in the database, but I don't work with that. When we read from the database, we immediately map the database model to an entity, right? And or an aggregate root, which is still an entity, and then we move from there, right? So we're like the database models will literally be like the thinnest layer. That I don't have it here. Let me actually open clean architecture because it's gonna be pretty similar. Yeah, we're focused on these things, and whenever we, you know, do the repository and database, basically this is where the database models will be, just here. From the repository to the database, and vice versa. When we read from the database, and I think these should be like this. When we read from the database, we immediately convert it to the entity and return that back into the application. So yeah, not a big deal, you know. We have the logic, we have everything. Persistence is just save, read, update, that's it. Yeah, pretty cool. I hope that I achieved that though. This is the first time that I'm approaching this. I'm basically approaching it, and this was good. I'm basically approaching the whole application from the bottom. So I started with the entities and the value objects and stuff like that. Now I'm at the application level where we created the commands. This is use cases. The diagram shows use cases, but it doesn't matter. It's going to be commands and queries. And then I'm going to get into the infrastructure and apply that, and then get into the presentation and start building some UI for this. But I'm basically developing the application bottom up. Start with the entities, implement the logic, go into the application layer to orchestrate all of the aggregate routes, you know, create, do this, do that, etc., etc., and then spend some time in the repository so that we can, have persistence, and then go to the presentation to build the UI. So that's when we have the full cycle, basically. But yeah, database and React, I'm leaving that for the very end. I want to build, the whole logic first. AF says, I know it's unrelated, but can you recommend resources about adding Sentry to my React Native Expo application? Your Goodbye Money series has Sentry episodes, but I thought it's worth a shot asking you just in case. I actually haven't done React Native in, I'm gonna say, maybe even exactly 2 years. It's been a couple of years already. But there should be a lot of resources on, adding Sentry to React Native, especially Expo. Especially Expo, because we have like wizards and stuff. There should be the wizards. And also there's session replay in available for mobile. You should try this. This is really cool. Yeah. There's the wizards. You pass the React Native, and it literally sets up Sentry for your React Native project. You added the DSN, the traces, sample rate, the profiles if you want to capture profiles. Yeah. Touch event tracking, automatic tracing, wrap it with the Sentry.wrap, and that's it. Yeah. Really, really, really cool. Yeah. I think it's just, you just run the wizard and that's it. It'll take care of everything. And there's no Expo specific things, I think. There used to be a special package, or maybe there still is, but there used to be a special Expo package. But no, that has been consolidated into one. npx expo install at Sentry React Native. So it is the same. It is that package, but there's an Expo thingy inside that makes it work with Expo specifically. But yeah, just run the wizard, and that should basically do the whole setup for you. There's also Expo docs if you want to check it out. I'm actually gonna paste a link here. Need to integrate Sentry into Courseful at some point. That'll be a project. What tech stack is Courseful? Evie said, do you think that there is a library like Dependency Cruiser in Python for this project? Let's see. Dependency Cruiser goes through your dependencies and it generates the image for your dependencies. This could be cool. So you can see whether, you're breaking the boundaries, etc. Ruby on Rails and Next.js. That's pretty interesting. I haven't done Ruby on Rails like ever. Your Next.js is going to be like a BFF, right? Backend for frontend. A proxy server to serve the UI and also interact with the Ruby on Rails API while you remain or keep the API hidden. Or if you put it in a Docker container, it's not even exposed to the world. It's an API, it's using Ruby because you're proficient in Ruby, but the server is actually Next.js. That's how you can have an API that is not open to the world. So you don't need to implement like security for it. But Evie, yeah, well, we should definitely like look into if there's like an alternative in Python. I bet there is. We just need to look into it. Yeah. Okay, so that's it for the stream, right? We did everything we wanted to do. We didn't worry about Django's user model or any database models. We just implemented logic. Now we have the Mediator thingy. Let me actually write this down so that we can be more prepared for the next stream. Hilariously enough, it's Ruby on Rails as a base and then SSG for Next.js. It's a sin, but it's how it is. It is how it is. You know, sin or not, that's your project. Okay, so after that, we actually implemented Mediator ourselves. We got the commands. And handlers. Going. That means for the next stream, we should focus on adding the tests for the create skill command. And we're probably going to use the mediator. Yeah, we're probably going to use the mediator to just invoke that within the test or not. I don't know. We'll see. Something to think about for the next stream. But yeah, Friday stream. Write tests for create skill CMD, short for commands. And we should also look if we want to use mediator inside of the tests or not. Should use mediator or test CMD directly. Yeah, that will be a question for for the next stream. I like writing tests for Django. Like test. What do you mean writing tests for Django? For Python or for Django? Okay. Yeah, this looks good. And we are done for today's stream. Really productive, I have to say. Like episode 8 turned out to be a really, really cool episode because we built some cool stuff. I find it more intuitive than just, yeah. Maybe really nice, indeed. All right, yeah. Have a great weekend, everyone. Thank you all for tuning in. 250 views, that is awesome. Thank you all for tuning in. In the next stream, as I mentioned, we'll just go and write some tests for the create skill command, and that's going to be pretty short, I believe, but still, we're going to start with that, and then we might, move into implementing the other aggregates that we have defined. Cool. All right, so take care, everyone. Have a great weekend, and I'm going to see. Wait, great weekend? No, the stream is on Friday. There's no weekend ahead of us. I'm going to see you all on Friday. Okay. All right, take care, y'all. Bye.